This is the mini version of the Psion Organizer recreation, and it's a Raspberry Pi Pico with a keyboard and a display and a SD card slot, and also in this one I've got a real-time clock chip. Now I've got a menu here to do various things with that chip. One of the things to display a clock with the time and date. And one of the things I wanted to do with this was be able to do this sort of menu display with OPL. Now I've rewritten OPL basically, and because of that I can pretty easily add commands to it, and also I can also hook in different hardware to the existing commands. So there's an hour, minute, second command, set of commands to access the time and date in the original organizer OPL. And what I've done is I've hooked those into the real-time clock chip that's in here. So if we go into the file menu and edit a file called rc3.opl, you can see that we've got a program here, standard OPL source code, cursor off, well, no key, at the top left, print the hour, minute, second, and they're standard OPL commands, hour, minute and second. There's also date ones. Now if we come out, I've previously translated this. If we come out and go into the program menu and run RC3, not 2. Oh, I've translated it. Oh well, there you go. So it's translated it instead of running it. I should have done R and RC3. And there we go. So that is running in the loop we saw, and it is reading the time by executing the hour, minute, second commands, which are going out over the I2C and reading the real-time clock chip. So we exit. Now, one of the milestones that I wanted to do was to add I2C to this, and I've now done this. So if we go in and have a look at a different program, the very similarly named RC2. Now this is doing the same thing, but it's reading the I2C clock using, after we set a few variables up and checking for a key and so on, using the I2C WRRD command, which is I2C write read. And this is issuing a write read command using some data. The write data is there, it's a 0, which means register 0, which is where the seconds are stored. And then it's doing that to the correct bus and address and so on. And the read data is in R string, which is a string which will contain as it happens, 1 byte, because we've asked for 1 byte of data. Some manipulation to get rid of the bits that are there, and then we turn it into BCD. And we do the same for the minutes, the hours, and then at the top left we display hour, minute, second. So if we come out and go to the prog menu and we run that this time, and it's RC2, you'll see it is also displaying the time, but this time this code is actually going out over the I2C bus and issuing I2C transactions to read registers, which means using that sort of approach and a set of commands, maybe you need a read and a write command as well, or write read with 0 bytes or something like that. I've only done the write read at the moment. You can actually talk to a real-time clock chip or any other device that can be attached to an I2C bus, and that is one of the milestones for this. So now I can make the GPIOs accessible, and you've got a little port on the side and you can talk to a wide variety of stuff. If you have other interfaces, SPI or just serial data or even some sort of parallel data, and you've got enough GPIOs, then you could write commands to interface to those protocols as well. So that's definitely a milestone. That's one of the things I wanted this to be able to do.